Hey everyone, it's Arvind, and today I'm going to show you guys how to do a Modelsim simulation. So in this example, we're going to take a component, duplicate that component in a structural architecture, and then simulate the structural architecture in Modelsim. So let's go ahead and get started. So this here is a half adder. It's pretty simple. It's just you have your 1-bit inputs, your 1-bit outputs, um, and then here in your architecture, you just have sum is A XOR B, carry is A and B. It's really straightforward. So that's all there really is to a half adder. But let's say we want to make a full adder out of 2 half adders. So that's what this is. We have a full adder. Here's the port mapping. And then in our architecture, we have some internal signals. And then because this is a structural architecture, we're going to instantiate 2 half adders. So this is how you instantiate a component. So here's your first half adder. Input 1, input 2 are going to be going into that one. And here's your second half adder, and sum 1 and carry in will be going into that one. And then carry out is assigned here, your overall sum is assigned here. So that's a full adder. Now we want to make sure that this works, obviously. So we need a test bench so that we can test it. So here's a test bench. We're going to run through every case for the 3 inputs. And then, yeah, let's just get into it. Okay, so here's a Modelsim project, and in this project, we need to first add our files. So right click, add to project, add existing files, and you're gonna add the files that you just wrote, or I just wrote, and then now you need to compile them. Normally the way I do this is if I write a file, I'll add that file into my project and see if it compiles. That way I can squash any compiler errors like right after I write it and it's still fresh. But in this case, all 3 are fine, so I'm just going to go ahead and compile all of them. Alright, 3 compiles, 0 errors. So that means we're good to start simulating. So we'll go up here, we'll go to start simulation. Then the file that you want to select here, your design unit, it's going to be the test bench file. Not your full adder, or not the thing you want to test, but your test bench. So in this case, we'll open our full adder test bench file. So this brings us to the waveform window. That's what this is. And here in this window, the objects window, we have our signals. So these are the inputs and outputs to the overall to the test bench. So like in our test bench, we assign values to in1, in2, and carry in, and that's reflected in once we start the simulation. But this is where you access your signals, and you can oops, did not mean to do that. But you can change the names of them, or rather the how they're sorted. You can change the radix, which is pretty helpful, but all our signals are 1 bit, so the radix does not matter here. And then this is also a useful thing, just makes it easier to read. But then over here, this simulation window, this is a really useful window, because if I click on UUT, that's my unit under test, which is the full adder. I have access to my internal signals, my sum1, C1, and C2, as well as the inputs and outputs of the full adder. So this is really useful because if I click that box, I have access to my half adders as well and their signals. So this is going to be really helpful later on in the semester when you have like hundreds of signals. Well, not maybe not hundreds, but you get the idea. A lot of signals to track, and a lot of components and a lot of moving parts. So you can really get into the really get in deep and debug. So this is extremely helpful and will be very useful. This is your project window. Let's say I want to like change something in my half adder. I don't have to quit the simulation. Instead, I can just like I'll go over here, open up my half adder. I'm not gonna change anything, but like let's say I change something. I could go right back here, recompile it, and then this button is restart simulation. So that's just a quick way of not having to quit your simulation, make your changes, recompile, restart your simulation. That's an easier way of doing it. And going back up here now, this is your run button. That means it'll run the simulation for the amount of time specified in this box. This is continue run. I'll just continue to run the simulation from wherever it stopped. This is run all, and I'll just run it until the simulation ends or forever. But that's about it in terms of like actually simulating stuff. So we're gonna go ahead and actually run this now. So 100 nanoseconds should be enough for the purposes of this. So I'll click run, and as we see down here, simulation finished. That's nice. So now we debug by looking at our wave window. And one thing that is super helpful looking at your waveform window is clicking this magnifying glass zoom full, because that scales the waveform to the size of the window. And it's like really helpful at the beginning. You can see a lot more information, and it's a lot faster than manually scrolling out. So that's really helpful. And then some other helpful things to like track individual signal values are these two guys, find next transition, find previous transition. If you have a really long waveform with a lot of changes, this is really helpful. But so let's go ahead and see if this thing works, if this full adder works. So in the beginning we have 0, 0, 0 for in1, in2, carry in. If you add those three, you're obviously going to get nothing, so that's good. When our carry in is 1, our sum is 1, that's good. 0, 1, 0, and sum of 1, that's also good. 0, 1, 1, alright, so now we'll have a carry, and our sum is 0, so that's also good. And then 1, 0, 0, sum of 1, carry 0, that's good. 1, 0, 1, sum 0, carry 1, that's also good. 1, 1, 0, sum 0, carry 1, good. And then when all three are 1, we'll have a sum of 1 and a carry out of 1 as well. So this works, and it follows the truth table exactly. So yeah, our full adder works, and we have verified that it works by simulating it, so we're good to go then. I hope this was helpful, and hope it was a useful introduction to Modelsim. And if you have more issues with it, you can find any of the TAs and office hours. But yeah, thanks for watching, and good luck on your lab assignments.